হ্যালো, হ্যালো, ঠিক আছে।
Hello, hello, hello.
Ladies and gentlemen, good afternoon and welcome to all the distinguished participants at the auditorium and those who joined online. It is my great pleasure and privilege to be your host for this prestigious occasion commemorating the 101st birth anniversary of the esteemed late Haridas Nandi. Alongside this commemoration, we have the honor of hosting a one-day seminar on the theme Industry and Foundry 4.0 concurrently. First and foremost, I would like to extend warm welcome and heartfelt thanks to all our distinguished guests, dignitaries, leading academicians, and the engineering professionals who have gathered here today. Your presence is a testament to the high regard in which we hold Mr. Nandi in the field of engineering. We invite you to join us for an afternoon filled with insights that promise to reshape the contours of engineering excellence. We begin by paying our respect and expressing our deepest gratitude to late Haridas Nandi, fondly known as Nandi Sahab, among his contemporaries, as well as many present here today. He was a veteran council member and made commendable contributions towards furthering the cause of our beloved institution, the Institution of Engineers India. His legacy continues to inspire us all. Now, I would like to invite our distinguished guest to join us for the inauguration ceremony. Professor Dr. Raju Boshak, Chairman WBSCII, Dr. N.P. Sinha, Director, Allen Global Services, Foundry Park, Howrah, Major General Dr. M.J. Siali, BSM retired, Secretary and Director General, II, members of Nandi Saab's family, Professor Dr. N.R. Bandopadhyay, former professor and head, Schools of Material Science and Engineering, IIEST, Shibpur. Mr. Anirban Datto, Honorary Secretary, WBSC, and E.R. Shubhrata Chandra, Member, MME Division, II. Do please come forward to water the plant as a mark of inauguration. This act symbolizes growth, renewal, and the nurturing of new ideas, the principles that Nandi Saab deeply valued. A big round of applause, ladies and gentlemen.
কঠিন লোহা কঠিন ঘুমে ছিল অচেতন ও তার ঘুম ভাঙাইল রে কঠিন লোহা কঠিন ঘুমে ছিল অচেতন ও তার ঘুম ভাঙাইল রে লক্ষ যুগের অন্ধকারে ছিল সব রে ও তার ঘুম ভাঙাইল রে লক্ষ যুগের অন্ধকারে ছিল ঘুম ভাঙাইল রে কঠিন লোহা কঠিন ঘুমে ছিল অচেতন ঘুম ভাঙাইল রে পোষ মেনেছে হাতের তলে যা বলাই সেতে মেনে পোষ মেনে
Thank you so much. Sure.
হাতের তলে কঠিন লোহা কঠিন ঘুমে ছিল অচেতন ও তার ঘুম ভাঙাইল রে কঠিন লোহা কঠিন ঘুমে ছিল অচেতন ও তার
Thank you so much. I now invite Dr. N.P. Sinha, our honorable chief guest, along with Professor Dr. Raju Basha, Chairman WBSCII, And Professor Einar Bandyopadhyay, an ardent disciple of Sri late Haridas Nandi, and the main architect of today's function, along with E.R. Anirban Datto and E.R. Subrata Chandra, to take their seats on the dais, please.
Yeah. Just for the awareness of the metallurgists present over here and engineers as a whole, that the last theme song of metallurgy, as I coined it, it is a song of Rabindra Sangeet. It is a Rabindra Sangeet, Rabindranath Tagore, and sung by Suchitra Mitra, the great Suchitra Mitra. And the words, if you follow, I will send this to all through WhatsApp, that the iron was sleeping, it was made to function, and in the second para it is written that the talur in the palm, if you take it, it can control the iron. That defines that by heating and cooling and heat treatment, we can make the properties. At that period, I wonder whether he interacted with somebody of Tata Steel that time, the founder, like Bose, P.N. Bose, you know, the geologist who is the Jamshedji's Tata's interaction, and this Tata Iron and Steel has been founded. Thank you very much.
Thank you so much, Professor Bandyopadhyay. I also request Dr. Debashish Desarkar, CEO, ICTDC, and Chair of the Technical Committee, along with the past Chairman of WBSC II, Dr. Ajay Kumar, our invited speaker from IIT Tirupati, past and present council members of II, Secretary and Director General II, and the family members of late Haridas Nandi to take their seats in the front row, please. It is our pleasure now to felicitate our honored guest on the dais. I would request E.R. S.P. Datta, former council member II, to present a flower bouquet and memento as a symbol of appreciation and warmth. To Dr. N.P. Sinha, Chief Guest of the occasion. A big round of applause, ladies and gentlemen. And the memento. Thank you so much, Mr. Datta. Then I would request Professor Dr. Sumit Chabri, HOD Mechanical Narula Institute of Technology and MMEII, to hand over flower bouquets and mementos to Professor Dr. Einar Bandyopadhyay, former Chairman CATE, MMDB and WBSCII, a student to his teacher, Professor Dr. Raju Bashak, Chairman, WBSCII. No problem. Here, Anirban Datto, Honorary Secretary, WBSCII. And E.R. Subrata Chandra, Fellow Member, MMEII. Thank you, Professor Chabri. May I now request E.R. Madhusudhan Mukhopadhyay, Senior Member, MME Division, WBSC II, and Major General Siali, SDG II, to felicitate Sri Haridas Nandi's family members with flower bouquets, please. I would request Mr. Mukhopadhyay to felicitate Major General Siali, SDG-II, please. Round of applause, ladies and gentlemen. Thank you, Mr. Mukhopadhyay. Now, without further ado, let us unveil the sequence of the events for this momentous session and to formally begin the proceedings. I now invite Professor Dr. Raju Bashak, Chairman WBSCII, to deliver the welcome address, please.
A very good afternoon to all the dignitaries on the dais, off the dais, and other distinguished personalities, members of IEI, ladies and gentlemen. On behalf of West Bengal State Center IEI, I would like to welcome you all in this today's program on commemoration of late Haridas Nandi on his 101st birth anniversary and one-day seminar on Industry and Foundry 4.0 organized by West Bengal State Center under the aegis of Metallurgical and Material Engineering Division Board, IEI. As you know, the West Bengal State Center is hosting 39 Engineering Congress in this year, and which will be held on Novotel, Kolkata from 20 to 22nd December. So on behalf of West Bengal State Center, once again, I would like to welcome you all in this Congress to take part in different events through your active participation. West Bengal State Center of Institution of Engineers India institutes the Haridas Nandi Memorial Lecture and organizes every year to pay homage to his memory. He devoted most of his spare time to this institution during various phases of his life. He was actively associated to a number of technical institutions like the Institution of Engineers, Institution of Indian Foundrymen, the Indian Institute of Metals, Geological and Metallurgical Institute of India, and other social and cultural organizations. Today's topic of lecture is emergence of concept of industry and foundry 4.0, reflection and introspection. Foundry 4.0 has anything to do with new emergent technologies, processes, procedure, and systems that have a socio-economic impact on how the foundries are currently operated. Industry 4.0, which means smart manufacturing, is the realization of the digital transformation of the field, delivering real-time decision-making, enhance productivity, flexibility to revolutionize the way companies manufacture, improve, and distribute their products. So speaker definitely elaborate the whole topic and enrich us about the theme. So with this, once again, I would like to welcome you all in this today's program. Thank you. Thank you.
Thank you, sir. Following this, I invite Professor Dr. N.R. Bandyopadhyay, Chairman H. Nandi Birth Anniversary Committee and former Chairman WBSCII, MMDB, and CARTE III, to share his insights on the occasion and provide a life sketch of late H. Nandi. Professor Bandyopadhyay's dedicated efforts have been instrumental in making this event possible. His stories and memories of Nandi Sahab will undoubtedly remind us of the values and principles we strive to uphold. Sir?
Thank you, Tania. Good afternoon, ladies and gentlemen who are online and offline, and also the distinguished guests at the dais, of the dais, my beloved friends from my alma mater, Secretary, Director General, former council members, family members of Haridas Nandi, and our distinguished speakers from Tirupati, IIT, one distinguished, another will be on the online. And my dear students, corporate members, and faculty members from across the country's various places. And as well as we have with us today the main contributor to the all technical programs which is happening around the country by the initiative of Headquarters Technical Department, and their executives are present over here. I extend my sincere thanks and gratitude to them. Well, you might be aware that to realize the laudable objective, the first Indian Industrial Commission, 1916 to 18, emphasized positioning engineering as a facilitator for the robust industrialization, leading to the economic growth of the nation, as well as the growth of science and technology in the global perspective in the jurisdiction of entire engineering and technological domain. Journey of architecturing this mission of the commission of a promising professional society was to establish, and that created the establishment of this great institution of engineers India in 1920, and under the Companies Act 1913, and further it is incorporated in Royal Charter in 1935. And eventually it is coincided with the establishment of quantum mechanics. And then onward, this institution started functioning and giving the quantum jump to cooperate and help and furtherance of the cause of engineering society as a whole and societal implication and growth. This Dr. Haridas Nandi, our beloved Haridas Da, was one of the main torchbearer of this great institution. It has its headquarters here at Calcutta, and it has already crossed 3-4 decades of his journey, contributing to the cause of science and technology and education through his 125 local and state centers across the country, 8 overseas chapters, and 18 international links. So their commendable contribution for the cause of the society is remarkable. This I mention because Haridas Nandi is a product of this institution, and like many product and many legacies for the posterity, this institution has produced. Commemoration of such a respected late Haridas Nandi, a pioneering metallurgist hailing from illustrious department of metallurgy, Bengal Engineering College, Shibpur, which stands as the second oldest in the country, and an esteemed council member of Institution of Engineers India, assumes an unmatched significance during the celebration of 101 years birth anniversary of this great personality. This momentous occasion stands as an emotional opportunity to bestow a befitting tribute upon the exceptional legacy. Born in March, 1st March 1923, he completed his matriculation from Nogon School in Bangladesh, which is still reputed school in this that locality. Further, ISc from the college in Daulatpur, Bangladesh, graduation in metallurgy from Shibpur in 1944. As one of the pioneering graduate in the field of metallurgy from Shibpur, he emerged as a phenomena on the horizon. His professional journey as a distinguished expert in steel foundry sorry for the interruption. Steel foundry and metal castings in Eastern India hinted at his eventual transformation into a legend. From 1945 to 74, he served the foundry and castings and manufacturing sectors in various capacities, West Bengal, starting from his apprenticeship to a general manager in NISCO, and finally an expert metallurgist and consultant for the foundry across the country. In this context, besides that, I should mention that he had a hunt for academy, and he served as a guest lecturer in B College, Shibpur, Metallurgy, Jadavpur University, Indian Statistical Institute, and Calcutta Technical School as well. One of our great teacher of B College, Shibpur, in metallurgy, he was supposed to come today, but unfortunately, because of his health, he could not make it. Professor Ajit Chakraborty was the alumnus of B College, stated that late Haridas Nandi, Haridas Nandi was a doyen of steel foundry industry in Eastern India. Although he was always engaged in industry, his teaching quality were excellent. At present, he is the present author. He was the author of Haridas Nandi 100 years memorial volume in memory, and he authored that, and he became the main admirer of Haridas Nandi and paid his tribute in this way he presented in that memorial book. However, the illustrious journey of Sri Haridas Nandi, who became the student member of IEI in 1946, AMI in 1954, and corporate fellow in 1970. He began the earnest journey with Institution of Engineers in 1956. So long journey, and spare time he always dedicated for the cause of institution. His family member sometimes was complaining, but later appreciating this. However, he was the man who was the first organizing secretary of first Indian Engineering Congress held here in 87. He was organizing secretary in 1987. I am adequately correct. And he was the first organizing secretary. And Haridas Nandi and me is I should say, I normally made no mistake. Even Hero can make, I cannot. Anyway, sorry. So, following a successful completion of this Congress, Nandi became the chairman of West Bengal State Center. He then became the West Bengal State Center, where I was also the chairman in 2004-06, and he was in 1986-88. Well, he was additionally functioning as a chairman of Metallurgical and Materials Engineering Division Board of Institution of Engineers, and served as a consulting editor for the metallurgical part of journal. Engineering concept of bifurcation. Engineering, actually metallurgy and materials was the initial division of this institution. He initiated and engineered the bifurcation of these two divisions to a separate division. mining and metallurgy. And later on, with the development of engineering, science and technology and materials as a whole, he has renamed it in the pattern of Kanpur IIT, Metallurgical and Materials Engineering Division in 1997. So he has got lot of contribution like this. Such a person who was in who actually scripted a book which is still in our library, IEI Marches Ahead, during his visit. So enormous contribution. Just a proper paper in a black and white cannot elaborate his contribution for the cause of institution and as a whole. I am the fortunate to have his guidance and mentorship to again serve this institution in a befitting manner as he desired and guided me. Well, ladies and gentlemen, this traditional motion of metallurgy was involved in extraction of metals from ores, their modification for particular use, pursued by Haridas Nandi and undergone significant transformation, which is now we will be discussing. So his period and now is a foundry as a whole has got a different type and perspective has changed. In this backdrop, we, the Metallurgical and Materials Engineering Division, planned or decided to hold his memory every year. Last year was a gala program of 100 years celebration. A book was brought out in the memory, and all the distinguished past presidents who were with him in council contributed, and there was very good 3-4 technical papers. One is by Professor P.P. Chattopadhyay, Director NIPT, one by Dr. Devashish Desarkar, my esteemed friend, and another was by Professor Ajit Chakraborty. And it was a gala program. So from there, we again thought that every 5th August, prior to that, we thought of doing it in 5th August. Centenary gave us a different boost. And this year also, with his memorial lecture, we are doing concurrently a seminar on industry and foundries 4.0, which we wanted to discuss over here to have a retrospection and introspection of the entire gamut of foundry industry, which is stated to be Sheffield in this part of the country. However, there is a long story if we go on elaborating about Haridas Nandi. Now I wish that let this prestigious seminar with our distinguished chief guest to talk after me, and also the distinguished technical sessions chairman and speakers will be here. One will be online. This will be a befitting tribute to the great personality Haridas Nandi. Let it take off, and I pay my rich tribute to the treasured memory of Haridas Nandi, and my heart touches his feet with adoration, admiration, and affection. Thank you.
Thank you, sir. Your speech really helped in setting the tone for an afternoon of profound insights and inspirations. Our esteemed chief guest, Dr. N.P. Sinha, as acclaimed foundry technologist, to address the gathering. Dr. Sinha's expertise and vision have always been a beacon for the engineering community. As we listen to his words, let's embrace the inspiration and insights he brings to this gathering. Before I invite our honorable chief guest to speak, I would like to invite A.R. Anirban Datta, Honorary Secretary, WBSCII, to formally introduce the chief guest. Mr. Datta, please.
Thank you, Tanya, for giving me the opportunity to introduce our honorable chief guest, Dr. N.P. Sinha. Dr. N.P. Sinha received his PhD degree in industrial metallurgy from the University of Birmingham, UK in the year 1973, and he worked in German and British foundries. After his return to India, he worked in L&T Foundry at Kansbahal, Bhartiya Electric Steel Company Limited, Kolkata, KMCL, Tisco, and Tata Yokogawa for many years. He was a consultant to many international companies such as International Mechanite Company Limited, UK, Gibson Centritech Limited, UK, and Unido, Vienna. He has been the foundry consultant to Refine Steel Company Limited, Kolkata, Titagarh Wagons Limited, Kajaria Iron Castings Limited, Kolkata, Super Smelters Limited, Durgapur, Nagpur Alloy Castings Limited, Nagpur, Orient Steel and Industries Limited, Kolkata. He has been adjunct professor in IIT Kharagpur from 1983 to 85 and visiting professor to many engineering institutions. Dr. Sinha is a fellow member of ICME, erstwhile Institute of British Foundrymen. He is also chartered engineer from London, fellow member of IIF and recipient of Best Foundryman Award from IIF in 1991. He has been associated with Center for Education and Training, IIF, since 2002. He has written digital modules on foundry topics for training in foundries, which has been translated in 7 Indian languages and helped in training thousands of foundry workmen across the India. Presently, he is the President Technical, Govind Steel Company Limited, Kolkata, Director, Alliance Global Services, Kolkata, and also mentor of CET-IAF and co-chairman of Indian Foundry Journal. Let us give a big round of applause for this great engineering personality. I now invite Sri Dr. N.P. Sinha for delivering his lecture.
Thank you, Mr. Datta, for your kind words. Good afternoon, ladies and gentlemen, and namaskar to everybody. I thank the organizers and office bearers of Metallurgy and Materials Engineering Division Institute of Engineers for organizing this seminar and inviting me, which I feel I'm privileged and honored. It's not the first time I have been here before, and it gives me further pleasure because I knew Mr. Haridas Nandi Babu Jahamna Bolta. He was very much involved with Institute of Indian Foundrymen, IIF. And I have been with IIF for the last 50 years. And in the industry, 48 years with IIF and more than 50 years in the foundry industry. So I'm basically a metallurgical engineer, but I've been in the foundry all the time. And mechanically, I've learned from you people a little bit. So I think, I will try to give my views to this apt lecture, Foundry 4, which is just the right one. It's not only required by the industry, it's more so required by the foundry industry. We say used to be Sheffield of India, this, that, and so on, which is no more. We have lost that crown. And today, I think the southern foundries and Rajkot and Rajasthan, they are progressing more than us. We had at one time, so the Chandra, he was with me, and I should know that we had more than 400 foundries in Howrah alone. Never mind India, but one other. Now it has come down to around 80. So this is the time when we need a push. Well, I mean injection, what I say. That how do we sustain this number? If we can't increase, it should go further down. And Foundry 4 is one formula which can help. I can say that, we boast about we are the second, we produce 12 million tons of castings per year. We are the second biggest in the world. Very big thing to say. But who is first? First is China with 52 million tons. How much the deficit? We are 40 tons per year behind. Just imagine when can we catch up? But at least, this will come to what this is foundry 4 is and what foundry industry or actual foundry online can benefit. But certainly it can show us the way, the path, which way to go at least towards reaching 52 million tons, which is not an easy joke. I say that. How long will it take? God knows. Today, topic foundry has been only chosen, as I said. Now, what is this foundry for? This magic word goes around in a buzz. Suppose foundry for, yes, it is there. What it is a foundry for is integration, communication, usage of data. Integration means that everything in production cells communicates with one location for data storage and retrieving, where the decision could be logically taken to improve the process, improve the productivity, improve the whole system of operation efficiently, more efficiently. Like, we, before Foundry 4, we have been in the industry. More than 150 years, the foundry have been working. So it's not that before Foundry 4, we didn't know anything about it. We were working systematically, things have moved. Foundry 4 is only a new thing. It's a brainchild of German government, not individual. German government somehow decided that this organized, we are going digital. So how we can deploy this digital, which is separately in CNC, CAD, CAM, this, that, and so on, together, to link them together so that there is a common platform, maybe the physical or maybe the cloud or whatever it is. So from there, things can operate much better, and they named it Foundry 4. Today, America is more relevant to Foundry 4 than any other country in the world. Now, as for example, I say what we used to do today, most of the foundries. I don't know how many of you have seen the foundry, but foundry is a place where with the sand along with the bentonite to make it moldable material, and we make the mold with the pattern, help of the pattern. Make the mold, open the box, strip the pattern out, close the box. That retains the hollow shape of the pattern. When we pour the metal, allow it to cool, take it out, and that's the casting. So now, this system to get the sand, now sand has to have certain property. Otherwise, the moment we lift the box, sand will drop. So it has to have some moisture, water content. It has to be bentonite. So if the water content is more, you will have, at high temperature, water dissociates hydrogen and oxygen. Oxygen goes away, hydrogen retains, is absorbed in the system. When you pour the metal, these hydrogen in fine bubbles, they give a defect known as pinhole defect. So, we have been working with this and in a system. There used to be moisture control system and so on. Now we have the PLC sensors. So, we have the monitor gives you as moisture coming through this mill going into the mold is 4.5% or 5%. Now, that is 2, 3, 4 steps before Foundry 4. because that is systematic data collection. Now that data on the screen or somebody writing it, that has become digital. Now that digital has become automatic by sensor through PLC and so on. So now let's go to the second thing. Now the sand, you need the sand for running a sand mill, making the 100 molds, maybe 200 tons. So, if the 200 tons comes less, somebody comes say, we sand is less, order that. Today we have a sensor. It says sensor, 200 tons, level come, order. Now that sensor, the data that has been collected and sent to the central pool. This is what from every operation, data is collected and sent to a central. That is for basic, I say, key operation system or magic of this foundry for data collection, understanding, and then giving back. The foundry has come below 200 ton level. Now is the time to order. So one man can do all the operation. It can do the sand. It can do the mold similarly. The mold line go further. It can say that 200 mold, some code has broken, so the line has stopped. I don't know, you have seen mechanized plant, your mold boxes one by one going on and on. Unless one is pushed forward, there's no room for the second one. And the second one doesn't go, the metal being tapped. What happens to that? So either that metal will go cold or we are holding it in the furnace, wasting electric power. Then, comes another thing. So we have to, all these things are today censored and brought to a central position. And that's what the smart foundry or foundry 4 going towards it. So we take it, we can elaborate, not pattern making. Then we can have the core making now, which has become the 3D printing. So there is no human error. You have the 3D drawing, put it there, and then you have the sand code made by 3D printing. So now, not only the core, today, French Matt patented, they are making metal castings by 3D printing, metal printing, not sand printing. That means you have a conical nozzle, you may have seen it in the Google and so on, conical nozzle. Metal powder comes from one pipe, and very controlled amount of laser beam comes at the bottom. It melts a drop, micro drop, which drops on the keyboard over, rotating over piece, and then next one and next one and next one. So you've got a casting, metal casting. There is no furnace, no sun, and so on. So maybe in 25, 30 years from now, there will be no furnace, no molding shop, no foundry. Take a drawing, go to that, metal printing, get a casting, foundry gone. But that's a different thing. I think it takes some long time to do. What I'm saying, that when this digital technology is moving so fast, internet moving so fast, that this is, if we can summarize, that this is what Foundry 4 has done. Now then, it doesn't mean that, human help is not required. You need to understand that we have to have the people, foundry savvy, who understand that cyber technique and so on. So if we have to train our people to understand this. Once you understand, follow things, there are definitely foundry benefits coming on. Like, the additives we have to learn in the certain subjects like, robotics, additive manufacturing, 3D printing, Internet of Things, IoT, what we call it. Simulation is very important. From the drawing today, in the casting, we have a lot of defects. Surface defects, we can see. There are some defects under the casting, inside the casting, which we can't see. We can only see by ultrasonic or by X-ray, which is not easily available. But, by simulation from drawing itself, we know surface area, the modulus theory is there, how much heat content in certain thick area is and where is not. If that is there, then we work out from our calculations so much heat content is there to cool that or maintain or compensate that contraction. We have to add certain material which is known as riser, so that there will be no shrinkage or defect in the casting. So it has come out the simulation. So these are certain things we have do that, and further, these data can go in the cloud. So if I have a foundry in Calcutta, another foundry in Chennai, and they can all draw these data and do the work from there. This has definitely benefit. It's not a, story like Ford has already started data sensor in a big foundry, 5,000 tons. BMW using the Express system, Siemens 3D printing, Bosch. They are using the cloud. They have several practice to do this. So these are certain things what Foundry Ford can do for the industry, and in turn get the benefit of quality and high production about the Foundry Ford. And here I would like to add one, as I initially said that we are only down to 80 foundry today. Now, I think it becomes our duty or it's a prerogative to help the foundries in this foundry phone system. At least they can take the discipline to work so that their productivity, their quality, their system is better. As an engineers, we can do this, and that will be glad. Thank you very much, giving for the time. That's all. Right.
I'm sure you are all absorbed with his illuminating deliberation, punctuated with his long experience in this field. Thank you, sir. Please, sir.
I'll just give you one thing, how this foundry hole is helpful. Please sit down. Just I'll take 1 minute. Very interesting. Very interesting. I had worked it out. Just one second, I'll check. See, melting, there's all the foundry have melting, cupola, or furnace induction furnace. Sorry about this, but I think you must know what is foundry 4 can do, and it's definitely going to help. When we say induction furnace, the definition is induction furnace specification. 1 ton induction furnace means 1 ton 1600 degrees centigrade steel melting temperature in 1 hour. 1 ton in 1 hour, 1600 degrees centigrade. If it's cast iron, 14, 15, maybe it less. So that means 1 hour, generally practically 5 minutes plus or more. Now, if we have 26 days in a month, by running 24 hours, then we have about 720 hours. That means we can make maximum 720 heats. That means 720 tons. Didn't get it? 1 ton per hour, 16 centigrade. If it's cast iron, maybe 5 minutes less. So 720 hours means 720 heats means 720 tons. Or say cast iron 750 tons. I'm associated with Govind Steel as introduction. Mr. Tata said that. They have 1 ton, 2 crucibles. And there, we have taken 950 heats in 1 month. I won't say it's foundry full, but it is. Because that furnace is connected to the melting software called as Melt Master, which tells you when to charge, when not to charge, when power is less, when power is more, heat planning connected to the memory. If the more line is stopped, you stop here, not to stop, switch it off. So it automatically does that. Now, if we do that in machine shop, CNC machine, all that, then it comes to the family phone. So family phone is the thing for future, and this we should the organized big foundries are doing it, but I think we should part of it modify and help our small brothers and small foundries in around Calcutta, Howrah, and Eastern region. Thank you.
Thank you.
Sorry about that.
No, it's all right.
So really appreciate your initiative with this deliberation. Thank you so much once again. We will conclude the inaugural session with the remarks from E.R. Subrata Chandra, fellow member MME Division WBSC IEI. Sir.
Hello, good afternoon, ladies and gentlemen, honorable guests of and on the dais, all the distinguished participants at the auditorium, all also who joined online. It is my great pleasure to be at the dais to propose the formal vote of thanks at this prestigious event commemorating the 101th birth anniversary of our respected late Haridas Nandi. Besides this commemoration, we concurrently are holding a one-day seminar on the theme Industry and Foundry 4.0. I believe the deliberation made at this inaugural session for the last 1 hour or so, you could realize the guest expectancy with which the illustrative events have been structured, and as such eagerly awaiting to listen to the technical talks. In the interim, we extended our deepest gratitude and profound appreciation to all the participants, esteemed guests, expert contributors, generous donors, family members of Mr. Haridas Nandi, and individuals who have directly or indirectly supported and contributed to the trump of this occasion. Our heartfelt thanks also extended to those unsung heroes who have diligently worked behind the scenes, their silent efforts having played an integral and indispensable role in the resounding success of this initiative. Thank you. Namaskar.
Thank you so much, sir. Ladies and gentlemen, please remain seated as refreshment will be served at your respective seats. We will start the technical session shortly to be chaired by Dr. Debashish Desharkar, CEO, Indian Copper Development Center and Honorary Life Fellow of the Indian Institute of Metals. And looking forward to the technical proceedings, I now hand over the podium to E.R. Anirban Datta, Honorary Secretary WBSC III. This is Tanya Kumar signing off. Thank you, ladies and gentlemen, for staying with me through this inaugural session. Thank you so much.
Thank you, Tanya. You have propelled the session, entire session, in an excellent manner. And now, on behalf of the organizers, may I now request Professor Dr. Enar Bandyopadhyay to present a flower bouquet to Tanya, the master of ceremony of today's session, as a small token of appreciation and remembrance.
Thank you. Hey, please be seated. ক্যামেরা জোর নেই নাকি ক্যামেরাটা গেছে থ্যাংক ইউ
I really appreciate it.
Now we'll take sir, now we can go on. Go on. এখানে এরকম introduction.
Esteemed participants, both on and off the dais, and also the participants who had joined online, and honorable guests. It is my great privilege to be on the dais to initiate the proceedings of the technical session of this prestigious event. It's my pleasure to invite now Dr. Debashish Desarkar, CEO of Indian Copper Development Center and also Honorary Life Fellow of Indian Institute of Metals, to come up to the dais and chair the technical session. And Dr. Desarkar, a metallurgist from the illustrious metallurgy department at Bengal Engineering College, Shibpur, graduated in the year 1975 and further did his PhD from the same institution under Calcutta University. His professional journey started with ICDC, which was formerly known as IIC, and he enormously contributed for the cause of transformation of the image of copper from transitional metals for the artisans in ancient days into a metal of strategic importance. A big round of applause for Dr. Debashish Desarkar. I now invite Professor Dr. Sumit Chavdi, my friend in the West Bengal State Center and a dedicated activist of IEI. And he is also the head of the Department of Mechanical Engineering Department in Narula Institute of Technology in GIS Group and an ardent and active member of the Materials and Metallurgical and Materials Engineering Divisional Subcommittee. He is requested to assist the session chairman as rapporteur. Dr. Chavdi. I now invite the distinguished speaker of the commemorative lecture, our beloved Professor N.R. Bandyopadhyay, an applauded engineer and most admirable fellow member of IDI, having laudable contribution for its cause. And also I invite Dr. Ajay Kumar from IIT Trichy. He is an expert in the Foundry 4.0 to take their seat at the dais. Dr. V.S. Sarvanan, Associate Vice President, Foundry of Indo-Shell Cast Private Limited, Coimbatore, Tamil Nadu, will join online and deliver his address. Now, it's my privilege to hand over the session to the Honorable Session Chair, conduct the proceedings, and let me have the pleasure to welcome him with a bouquet of flower and memento. I, I now request Dr. Debashish Desarkar, Honorable Session Chairman, and Professor N.R. Bandyopadhyay to kindly be on the dais. Also, I invite Professor Dr. Sumit Chavdi, and I invite Dr. Ajay Kumar from IIT Trichy to be kindly on the dais.
Skin navi do, skin navi do. সেটা তো করবে তারা স্কিল কেন জেন্টিয়ারকে ফেলিসিটেট করবে ইয়ে দেবে তুলে রাখে কিন্তু কাজ করা এইটা দাও এখানে আছে এখানে দিয়ে তুমি করবে এটা Well, ladies and gentlemen, please be seated. And we'll now go with the technical proceedings. First is felicitation of our Honorable Technical Session Chair, Dr. Desharkar, by our Honorary Secretary of West Bengal State Center. Dr. Desharkar, already, as you already aware, that is my esteemed friend, a CEO of Indian Copper Development Center. It was actually Indian Copper Information Center was earlier when he joined in 1976 after passing out from B College. However, I will not elaborate further. He is a graduate from our batch in the same B College. Further did his PhD. And another important phenomena is he was a very distinguished I should say, member of Indian Institute of Metals. He started with actually as a member, then he became joint secretary, became joint treasurer, and his long services at this stage, with the last council, he was honored as an honorary member, which is the highest honor by Indian Institute of Metals to a member for his distinguished service to the cause. So, a person from copper industry who made transformed, as Dr. Datta has already, Mr. Datta has already told, he made it to transform from an ancient metal used by artisan to a strategic copper for strategic industries. So, remarkable contribution. I will not tell in detail where he was, how he was, and what is his contribution. An esteemed engineer, worthy of the term. Thank you very much. That's all.
Thank you. Thank you, Professor Bhundarabhi, my good friend. And to start this formal part, I would like to take this opportunity to thank Institute of Engineers for giving me an opportunity to be on the dais today and extending a very good afternoon to all of you. And at the same time, convey my sincere tribute to this. Okay, photograph is not there now to put us the well-known foundry technologist of the country. Foundry was in his heart. It is quite apt that on the 101st birthday of late Haridas Nandi, we are going to have a seminar related to foundry operations. I come from the copper industry. It's one of the earliest metal to be worked. Today it is becoming a critical metal. Melting and casting to make cast products was the first metal fabricating operation done by the human being in any part of the world. Slowly the mechanization came in, technology came in, production volume increased, and thus more and more responsibility came on the metal casters, the foundry people, so that the process yield improves, product quality improves, and so that the process economics becomes more favorable to the industry to run. And the added parameters now the foundry industry has to look into is the environmental issues, and also the recyclability issues. We are talking about Foundry 4.0. The concept is computational and physical involvement, physical compatibility with the human being. We should, I am sure we will know more about from the speakers, non-speakers, how much ready we are, the Indian foundry industry, whether we have to make a leapfrog from industry 2.0 to foundry 4.0, or it will be a smooth transition. I'm eagerly waiting for the presentation of the speakers, and I'm sure once the deliberations is over and discussions take place, we go out of the hall, will be more illuminated on what is the future going to be. With this, I would like to introduce my good friend again, formally, Professor Dr. N.R. Bandabhadra, the first speaker of the day, who is an FIE, FIACT, former professor and head, School of Material Science and Engineering in Institute of Engineering and Science Technology, IIST Shippo, which was earlier known as B College, from where we all passed out. Professor Dr. Bandabhadra did his graduation in Bengal from Bengal Engineering College, Shippo, Masters in Metallurgical Engineering from Jadavpur University, and further did his PhD from Calcutta University. He has a wide experience, 15 years of industry experience prior to joining the research and academic pursuit with Indian Institute of Engineering Science and Technology, his own alma mater. He became the visiting professor, and he was the former head of the department of School of Material Science and Engineering, which is a part of B College. His teaching, he has guided more than 25 PhD theses, and which have been awarded degrees and 2 under final evaluation stage. It's a great achievement in a lifespan of a professor, and he did deserve well appreciation for this purpose. He has contributed significantly in developing high-strength steel and engineering materials with 2755 citation and 288 in index. In recognition to his contribution to the field of advanced steel, he has recently been entrusted by the Ministry of Steel, Government of India, with a national project on capacity augmentation in collaboration with Tata Steel. He has also represented Indian scientist delegation in Australia for the development of collaborative programs with leading Australian universities and nano composite for clean energy and under the IASRF program of the DST Government of India. He is the recipient of Eminent Material Scientist Award in 2004 for his contribution for the cause of material science, which is a very big achievement in the field of material scientists in our field. He is the chief editor of IEI Springer Series D Journal, Springer Series Journal D, dedicated for the metallurgical and materials engineering professionals. He is the editor of the Institute of Engineers, and he is the fellow of the Indian Institute of Engineers India and former chairman of the Committee for Advancement of Technology and Engineering and Metallurgical and Materials Engineering Divisional Board, MMDB. He is former vice president and the present council member of Material Research Society of India, MRSI, another very internationally well-known organization. He is a member there, council member there, and he is also the fellow of West Bengal Academy of Science and Technology, India. Without I had to reduce, as he has achieved many more laurels in his life, in his professional career. But I now request to deliver the commemorative lecture and the theme talk, which is emergence of concepts of industry and foundry 4.0, reflection and introspection by Professor N.R. Bandyopadhyay. Professor, now it is your time, please.
Well, thank you, Dr. Desarkar. My esteemed friend, again, more elaborately told about me, but I'm not. I'm a nanomist. Anyway, so first at the outset, I pay my rich tribute. Dr. Nehru, pay my rich tribute to the August gathering over here. Haridas Sandhi is my mentor. It's all right. It's all right. Please. Is my mentor. So my memory, it's a bond beyond measure. Reflections of my mentor, C. Haridas Nandi. My tribute to him with adoration, admiration, and affection, I have already told you. So, a man with foundry, having illustrious career and contribution in the old days, deserves a rich tribute from all of us. And I therefore coined my lecture in a fashion that how this changed over the year from the ancient human origin, today's paradigm shift has happened, and how it is affecting the present day industry scenario, fourth revolution, and also the fourth foundry is coming into this. So, just a prelude. Which one is it? Arrow? No, anyway, I think I should go by up and down. So I coined this in a fashion that's emergence of concept of industry and foundry 4.0, a reflection and introspection. My designation you already got it. So now just a prelude to what I will be telling. You could know that we live in an ever-changing and evolving world, but changes are not always comprehensible. The former discovery of wheel in 8000 BC to modern electronics computer, 1945 to 1950. 10,000 years has passed, and human has created, discovered, invented, created, developed new thoughts, without any punctuations. Although the Charles Babbage design of mechanical computer 1934 to 100 years realized the electronic computer, but if we go 35,000 BC approximately the human origin, some major discovery and inventions. This major discovery and invention includes 250,000 BC survivor tool, and then bow and arrow. Oh my goodness, what are you doing? Nonsense. Oh. Full screen has to do. Full screen. Oh my goodness, how people will see here. Anyway, sorry for the interruption. So sorry for the interruption. Just have a look to it. There's major discoveries and invention before birth of chaos, and 35 is the origin of human, and then survival oldest tool, copper craft, copper artifacts common in Middle East in 6000 BC, 35,500 BC the potter wheel, Chinese developed the printing press in 350 BC, and then the geometry, elements of geometry in 300 BC, 200 BC Archimedes, the earliest record writing mechanics, and then the Chinese mathematician introduced the negative number. So again, if we see the invention that changed the entire world, that includes the major discoveries of the last 2000 years. 150 AD, Ptolemy model of solar system, geocentric model. Then beginning of chemistry, Copernicus heliocentric model, and then Galileo in 1610 telescope observation, William Harvey blood circulation, Newton laws of motion in 1687, and again universal gravity, and further that James Watt developed the improved version of steam engine, and most interestingly 1805 John Dalton's atomic theory, the revolutionary creation, and then Einstein's relativistic theory, and more interestingly in 1920, as I was telling you earlier, that this is quantum mechanics, which changed the entire system of classical mechanics, and new definition of classical mechanics came up. So, ladies and gentlemen, now if you just look what we got out of it. So it's a combination of technology, innovation, and driving force is science and technology. And driving force science, where the Nicholas Wode in his writing of science stated that science is a series of peaceful interludes punctuated by intellectually violent revolutions. And then again, another great scientist, Einstein, told that scientist investigates that which already is, and engineers create that which never been. So we have to now look in a different perspective, and out-of-box thinking is the call of the day with the awareness about the societal need. Now, this calls for paradigm shift in engineering, science, and technology. I should say paradigm shift means impending paradigm shift in science and technology. Now, how this paradigm shift is coined? And then another scientist told about the origin of paradigm shift. He coined in his book, Thomas Kuhn, in his book, Structure of Scientific Revolution, he stated that in 1962, he argues that evaluation of scientific theory does not emerge from the straightforward accumulation of fact, but rather from the set of changing intellectual circumstances and possibilities. That's the crux of the thing. How we have transformed from where to now. We have to relearn, unlearn, relearn. So, next, now the historical example of paradigm shift, and taking in consideration this Kuhn paradigm shift concept, you could see that transition from Ptolemy cosmology to Copernicus. Another phenomena is Maxwell unification of classical Newtonian coherent mechanical worldwide, and transition between Maxwell electromagnetic to Einstein relativistic worldwide. And again, the transition between the Newtonian physics and the Einstein relativistic theory, and development of quantum mechanics. The most remarkable in recent times, or more than 100 years, that development of quantum mechanics which redefined the classical mechanics. And more importantly, as you are all aware, that Darwin's theory of evolution by natural selection, which overturned the Lamarckian theory of evolution of inheritance in the upward characteristics of human. So, complete paradigm shift from a concept to a concept by the discoveries. And it is not the straightforward equation of noting down the scientific development. It's a question of intellectual input by the number and groups of scientists together to make this shift. In this context, just we go to the historical uh, perspective of our ages, where the Stone Age to Bronze Age, my good friend will tell it is Copper Age, and then to Iron Age, and then to Engineered Materials Age. Now we are at the Engineered Materials Age. We are not depending on the resources and in processing. We are depending on the element, and as per my wish and as per requirement of the application, we combine it, put it in a different way, and it's like a building block of building, make it. And now again interference. Very intelligently you must listen to that interference of the theory of nanotechnology that Feynman told in 1959 in a meeting, American Society of Physical Sciences, that there are a lot of things at the bottom and which can give a technological revolution. So nano has interfered, and we are now in an era where everything can be done. It is not a buzzword. It actually can be done. And another interesting phenomenon in the recent days is that we were talking about the carbon dioxide, pollution. Everything is carbon we are attacking. On the contrary, the creation of graphene, which is a allotrope of basically carbon, which is a zero actually 2D material, but a zero band gap material. And this can revolutionary to high strength, high ductility, high, and if you combine with graphene oxide, it's a remarkable thing. So this carbon which was rejected by us, which was afraid to us, and we are talking about carbon footprint, etc., that carbon is now giving us a new dimension. So people and scientists are telling nowadays, that now this scientific revolution is coming at the tip of the pencil. Means this pencil we used to, which is lead, carbon lead. So this, what I wanted to impress upon, that this Foundry 4.0 is actually a paradigm shift from a concept to a concept, which we cannot do now. From a can't do situation to a can do situation, we are arriving. So this is the revolution, first, second, third, and fourth industrial revolution. All are combination of, number one was mechanization, number two was mass production, number three, computer automation, and cyber and physical system, which we are now attempting and doing. In the same line, foundries must follow the trend. That is which we are approaching to a, and we must, but unfortunately, we are still at 0.3 level for the foundry. And to go to the 4.0, there is a wide gap between, and we have to address this. As Sir was telling, Dr. N.P. Singh, that 90% of manufactured doable are castings, as stated by American Foundry Society, and that are used in automotive, space, general engineering, agriculture, and where not, maritime sectors, etc. So use of casting and importance of foundry is huge and immense. So we must address it in the right perspective. How to do it? Then again, just bit of towards Foundry 4.0 if you wanted to go, have a review. The castings are normally produced by a wide variety of different casting process. My young friend was telling that investment casting, when we were just interacting, sand casting, permanent mold casting, investment casting, high pressure die castings, cell molding casting, centrifugal casting, lost works, we say, lost foam casting and many others. And incidentally, these processes needs market segment where variability is to be addressed. Means casting size, geometry, complexity, achievable tolerance, material performance, surface quality and production and volume. The difference between the casting processes are so unique and immense that all these foundries can be treated as an industry. And they have got this separate methodology, separate concept of digital movement. So every foundry is such a complex or such a unique system and old days from these days that you have to really address this in such a right perspective that you can really address it. So, but the current image of foundries are not great in India, and industries are also aware of it. So Industry 4.0 principles adoption in foundry is a difficult task altogether, but we are progressing. When now I just refer that in August 2006, editorial of Modern Casting magazine says by it is published by American Society, has titled Our Image Sting. It is the editorial title, which implies by which state that foundries are hard, dirty, and dangerous. So it hard for foundries to attract the top talents, as Sir was telling. Skilled people, which was the main asset of our Howrah foundry. Skill, not an engineering degree. It is a foundry skill. So that's where we require the top talent to introduce. Moreover, the extraordinary complexity of foundry processes, especially methoding of every casting, requires well-educated technicians and engineers having multidisciplinary knowledge. Minded, we have with us today some mechanical engineers present over here. So I would say that this multidisciplinary knowledge includes, besides metallurgy, fluid dynamics, heat transfer, and the chemistry as well. I think our Professor Brahmo is here, he will appreciate. He is a chemical engineer from IIT Kharagpur. So again, we further discuss on this. Therefore, foundries find it increasingly difficult to recruit enough skilled work. Industry 4.0 concept, just mind it, that Industry 4.0 concept offers the possibility to mitigate this problem. The skill level required from most of the employees will be highly technical, but broad and generic in nature. Mind it, it should be generic in nature, which has been emphasized, and many jobs would overlap with IT sectors, which currently the most attractive for the young talents. So in the change, you could see that with the change of lifestyle, technology development, advancement, we have to tune with. And since their job would be office-based and away from the dirty shop floor, attracting skilled employees by foundries could become the easier in future. That is also then anticipation by the foundry for conceptual propagator. I will come later. Of course, we have a special attraction, that is high pressure die castings. They are automatized for a long time. Every from metal pouring to die spraying to part ejection are usually performed by the robots and manipulators. I was discussing with my friend present over here, Rana Banerjee. He was telling that you were telling about 4.0, etc., and digitalization, but robots were used for a long time. I told yes. And at that, we'll see in the next slide that actually these are the situation or condition which make ideal for adoption of Foundry 4.0 or Industry 4.0. But in case of sand foundries, often it's far from automation. There are some sand foundries which are employed automated guide vehicle and wide array of robot. Answer to my friend's question, robots are sometimes used, and in mechanical engineering sector, machineries for their their operation also is in the CNC machines and all. But most of them finds at a most of the foundries automation level is very poor. So that is the difficult task and significant bottleneck for industry 4 to convert from the present situation. So towards foundry again, we say that foundry processes are very energy intensive, which my good friend Dr. Devashish Desarkar was telling, the energy and environmental is the concern for foundry industry. And so adoption of foundry 4 concept, smart manufacturing. Sir was telling smart manufacturing, smart foundry is the approach for reduction of waste, increase of process efficiency, and consequently ensuring the beneficial effect in the local economic standpoint as well as global lifestyle standpoint. So as I could perceive, that foundry industry 4.0 is often rebranded as a management 4.0, foundry 4.0, and or logistic 4.0. So foundry 4.0 refers to inclusion of these stated principles into foundry industry. So, which implies that end goal of anticipated industrial revolution in foundry 4.0 factory, where customers' orders will be placed via a centralized control system and using integrated materials requirement planning or ERP in enterprise resource planning, and factory needs to control the supply chain and a production automatically in an autonomous way. Secondly, so taking all into consideration my discussion in the previous slides, in lieu of conclusion, I state that this goal is not easily achievable. Many years will pass before foundry 4.0 becomes everyday. Lots of technological advancement needs to be made to fulfill them, and the foundry industry needs to react now. That is most important. They are reluctant in some cases, and that is why from 400 foundry to 80 foundries in Howrah, they have now addressed the pollution control issues in spite of mandate of the society. But more importantly, the workforce. Instead of machinery and electronics, it should be workforce that can follow the current industry trend. So, and in the development pattern, in the development partnership, in the supply chain that are capable of horizontal integration. All people, all partners, all should be in the horizontal integration that will give rise to the foundry floor as a reality. Well, gentlemen, so summary wise, or again a conclusion I could say from entire, that agent of change is driving the new paradigm shift today in every sector of engineering, science and technology. Change is inevitable. You can't restrict. Multidisciplinary engineering science integrating the science with engineering has created a new demand on the engineering and technological institutions and has consequently brought in a new challenge for them. So with this in mind, we have to move forward, and from old days, our banyan tree at Botanical Garden, alma mater of B College, we were read, and thank you very much for patient hearing.
Thank you, Professor Bandyopadhyay. It was an excellent presentation. I'm sure I was at least, and I think everybody was spellbound. The nice way you started with the historical development of the paradigm and coming to very down to earth need of the foundry with regard to investment on workforce, in addition to investment on technology, equipment, and also touching upon the West management. Today's concept in the circular economy is West to wealth. And your last comment is definitely have to keep in mind the change is inevitable. Change will take place, and we have to, the industry have to gear up. Mentally, we have to accept it. Thank you, Professor Dr. Bandyopadhyay, again for an excellent talk. Thank you very much. Next speaker is here, Professor Dr. Ajay Kumar, who is Assistant Professor, Department of Mechanical Engineering, IIT Tirupati. The topic of his lecture this afternoon is Role of Digitization in Found Industry and Opportunities. Before I hand over the floor to him, I take this opportunity to briefly read out his very interesting resume. Dr. Ajay Kumar did his Bachelor of Engineering in Mechanical Engineering from Madhur Institute of Technology and Science, Gwalior. Then completed his MTech in Material Science, Materials Engineering from Maulana Azad National Institute of Technology, Bhopal. And in 2010, he received his PhD in Mechanical Engineering in March 2016 from IIT IASC Bangalore. And thereafter, he moved to US and obtained two postdocs, one from Washington State University, and the second one is from University of Wisconsin. Since 2019, Professor Ajay Kumar is with the Department of Mechanical Engineering, IIT Tirupati. His area of specialization includes advanced metal casting, metal forming, materials processing, and mechanical behavior of materials, tribology, surface engineering. He has several publications, published in international journals, in book chapters. He has 4 patents in his credit and presented 43 papers in various international and national conferences. To break down his 43 in international and 12 in national. Excellent. He was awarded the 72nd Indian Foundry Congress award was given during the Foundry Concert of 2024. The award was Chandran Menon Memorial Award for Applied Research and Innovative Technology for the year 22-23. So these innovations will be very much useful to all of us. And in addition, his lecture will be very apt for this program as he is running a Foundry 4.0 Students Activity Center in association with IIF Chennai and organizing several programs, including the certification course on AI ML for Foundry industries. In again association with IIF. Over to Dr. Ajay Kumar. We are keenly looking forward to presenting this. Please.
With permission of the chair, before Dr. Ajay Kumar commences his lecture, it is our customary on our part to felicitate our previous speaker, Professor Dr. Inar Bandyopadhyay. May I take the pleasure to request Dr. Sumit Chabri to kindly felicitate Professor Dr. Inar Bandyopadhyay.
I got one in inaugural session, so I am returning back to the organization. May I now request you? It's okay.
Now, Dr. Ajay Kumar would like to, Professor Dr. Ajay Kumar will make his presentation. Over to you, sir.
Thank you so much. Oh, Red man is vehicles. Okay. So thank you so much. At the outside, let me pay my humble regards to the feet of late Haridas Nandi on his 101-year birth ceremony. And I'm humble and feeling regard to be here. I'm thankful to Professor N.R. Bandyopadhyay for inviting me at this occasion. Suddenly I received one email from him that and then he wants to talk to me immediately or something urgent. I saw his email, immediately I call him back, and then he told that yes, we are doing this program and I have to come. Immediately I said yes, I will be definitely coming. So thank you so much, Professor, for giving me this opportunity to discuss and present my work in front of you. So without any delay, I would like to discuss the role of digitization in foundry industries and what are the opportunities for foundry. So, okay. So most of you are aware about the foundry processes. So I'm not going to discuss those foundry processes. Even the material science and metallurgy also I am not going to discuss. Most of you are experts. What I am going to discuss about the how we can work on the product life cycle, the product which we are making using the foundry process. Now the foundry 4.0 tools are there, and we have every day we are doing a lot of R&D work and implementing into the new materials. So we need to understand the product life cycle. So the entire process of implementing the latest technologies, including the Foundry 4.0 or Industry 4.0 tools in the manufacturing sectors, is to increase the product life cycle. Okay. So we are talking about two worlds. One is the physical world, another is the digital world. Okay. So all of us are doing physical activity every day, from our day-to-day activities as well as in our office, in our working place. So we are having a lot of physical devices, we are having a lot of sensors, and then collecting a lot of data using different devices. And then another world is the digital world, where we need to monitor the data, we need to store the data, we need to do the analysis of the data, and based on the analysis, we have to take the decision, okay, whether we have anything is going wrong in the process, and then we can take the immediate decisions and then work on physical world, digital world together. Okay, so this is how we are today discussing about the data science or data analytics. Okay, so the everything is dependent on the data. So data is the fuel today. Okay, so we have to take care of the data. So most of you will be seeing these images in various books and the platforms, that we are talking about the digital twin in industry 4.0. Okay, so basically when we have the physical world and then we have the digital world, we have the physical machines. So now the concept is digital twin. Can we have the digital process of the entire physical process we have. Sorry. Yes, yes.
Is a PDF, it is not PowerPoint, it is a PDF file, I guess.
Yes, yes.
You should have sent a PowerPoint.
1 minute.
Anyway.
Yeah.
So the slides you have to read out, you don't read out. You explain.
No, I will read out. I'm explaining. I'm explaining. Yeah. They don't need to read out. Yeah. Yes, yes, yes. I'm reading. So basically, we have the digital twins in Industry 4.0. So basically, we create the replica of the physical process in the digital form, so that we can see at the monitor or monitor. Okay, and then we can collect the data and then do the analysis. So when we talk about the foundry automation, so basically when we talk about the 4.0, we are basically focusing on the automation. We are going from the manual process to the automated process. Now, most of you are aware about the foundry process. Foundry is the laborious industry. Okay. And today also we need a lot of skilled people to work in the foundry. And if you see the real foundry industries, I have been involving with many foundry industries. When we visit those foundry industries, they would like to improve and implement the Foundry 4.0 or Industry 4.0 tools in their foundries. But at the same time, the machine, they cannot change the entire machinery. It is very difficult to change the entire machinery. So they would like to implement these Industry 4.0 tools, but in some particular sections. For example, we have the maintenance section, we have the data management section, okay, and then we have modeling simulation sections. These are the different sections where these foundries are implementing these tools and then improving their performance and efficiency. So Foundry 4.0, basically it is implementation of the newer technologies, and these technologies basically are improving the efficiency of the process. Okay. And Foundry 4.0, basically it is the subset of the Industry 4.0. Okay. So Professor Bandyopadhyay also was telling about the management 4.0, right? So basically these are all our subset of the Industry 4.0, and we are improving the aspects of the foundries: safety, quality assurance, supply chain information, efficiency, data analytics through the automation technology. So we are implementing the automation tools into the physical foundry process and then improving the efficiency. And that efficiency improvement can be in the form of the reducing the defects in the castings, and then improving the production rates of the industry. Okay, so there are many ways we can improve the efficiency of the casting using the Foundry 4.0 tools. And so these technologies can also be included: smart die casting, and then AI, machine learning, robotics, cloud services to manage data. Okay, so even I have seen now in southern region, many foundry industries have started implementing the robots in their workplace. Okay, so many things, many operations are being done by the robots. Okay, so robots are being implemented in the foundry industries, and then the cloud services are being used for managing the data. Okay, because everything you cannot keep in the computer, because you need the storage, you need the memory. Okay, and then every day you are generating a lot of data, and sometimes these data create a lot of problems, and sometimes systems don't work. So Industry 4.0, it is not one technology, but is a combination of modern technologies and to create the smart factory. Okay, so the entire agenda is to create the smart factory using the Industry 4.0 tools in the foundry industries. So that is how we can make these foundries smart, and our people can take the smart decisions wherever is required during the process. Now I have put some examples in my PPT. If you take the example of the silica sand monitoring by a smart system, how can you monitor silica sand? Because most of the foundry industries are using the sand because it is easily available, it is cheaper, economical, right? And then we can do the mass production as well. So many foundry industries are using the sand, silica sand. So now can we monitor the silica sand in the foundry system? So when the sand drops below the reorder level, the smart factory automatically places an order on the sand supplier for the entire quantity of the sand. So whenever there is a lack of the sand supply, if you have the smart factory in your foundry, you can take the quick decision and then place the order and for the getting the sand. Okay, so if the same system we can implement into the control system within the foundry and use the data from the material consumption, we can predict the sand chemical consumable requirements for the coming week or month or years together. Okay, so that type of predictions we can make using the foundry 4.0 tools if we implement. Now, interaction between value generation, common challenges, and enabling technologies. So when we need to give the skill to our workforce in the foundry industries, okay, we have to basically enable these things. First is the value of digital twin. Second one is the enabling technologies. Then we have the common challenges. So it is not like that we will implement these foundry 4.0 tools in our foundries and then we will be happy and we will get the full efficiency. It is not like that. So when we bring new technologies in our system, the challenges, there are several risks also are there. Okay, so I'm going to discuss those risks which we need to take care during the implementation. So I am not going to discuss all these topics. These topics we cover in different platforms. So when we talk about the value of digital twin, we have to see the real-time monitoring and control. Then we have the predictive maintenance and scheduling. And then we have risk assessment. Then we have better documentation and communication. Okay, these are the things which we cover in the digital twin. And I have mentioned the digital twin is the replica of your physical process. Okay, so everything you can see on the digital platforms, we create the different dashboards. Okay, when you create the dashboards, you can see everything on the dashboards and control those things. Then we have the different enabling technologies. We have physical based modeling, data driven modeling. So simulation and modeling is very important part of this of these automation tools. And then we have the different challenges which I am going to discuss in the few next slides. So we have this is basically the example of the product manufacturing digital twin model. So you have the physical layers. So you have the machines, you have the robots, then we have network layers, you have the different network connections. Then you have the data layers, the data which you are collecting from the different platforms in the workplace. And then we have this cyber layer. So here basically we think that yes, it is looking good, but there are a lot of threats are here in the cyber layer. So now there is a new concept called the cyber security. So whenever we have this type of data, then the cyber security will be very important because there will be a chance of hacking your data, hacking your systems. Okay, people can come and hack your systems and they can take your data and then do many things. So you have to be very careful when you are working on the data and then on the cyber layer, and then we have different type of application layer. So basically these two layers become very important when any foundry industry implement these foundry 4.0 tools in their industry. So we have seen the difference between the traditional and digital twin supervised in the manufacturing system. So you can see here, we have the industry 4.0 here. You can see the physical twin. This is the physical domain. And then we have the digital domain. So we are creating the digital twin for the every physical process. And then we have this sensor data maintenance here. So you can see here we are doing data analysis. We are developing a lot of machine learning models. Okay. And then here we have the physical domain. So this is the first half is called the industry 4.0, and then this one is the traditional. So we are basically moving from traditional to the industry 4.0, but at the same time we have to take care of the different challenges which we are going to face during the process or transition. Basically it is a transition. So we have seen the application. So you have physical world, then we are using different type of sensors, RFID. Okay, so nowadays there are different type of sensors. Okay, we have temperature sensors, we have humidity sensors. Okay, and we can also have acoustic sensors. So suppose any defect is coming in your casting. Okay, if we have some type of acoustic sensors inbuilt in the system, as soon as the defect comes in the casting, it will give you the signal, and then you can immediately take care of that defect. But most of the time, once defect takes place, you can work on the further process whether defect will not take place. But is it possible to rectify that defect or heal that defect? So for example, nowadays many of us are working in the area of healing the cracks. Okay, self-healing the cracks, self-repairing the cracks. So can you heal the crack? Can you repair the crack? Okay, during the process. So we are now implementing those AI ML tools to detect the cracks in the process. So basically it is known as in situ detection of the cracks. So now we are also implementing some of the healing mechanisms in the material process itself. So suppose we know that there is a cut in the material. Okay, immediately the healing mechanism will be activated. Like in our body, we have a small cut, blood starts coming, right? Then signal goes in our mind, immediately we get the heal, right? So similar concepts now we are trying to implement in the material itself. Once we get the crack or defect in the material system, we are going to implement some of these healing and repairing mechanisms. And during the operation process, if we come to know, okay, there is a defect, then we will activate these healing mechanisms and your crack or defect will be healed. Okay, so this is how these AI ML tools will be helpful. Okay, for improving the performance of the entire system. So we have sensors, we have RFID, and then we have virtual mold. So as I mentioned that we also need to create the digital models. So geometrical model, structure model, materials model, all of you will be aware, right? And then we have different type of process parameters. So all these things will go hand in hand, and then all these things will be combined in the digital twin models. So yeah, so if you see today's foundry, if you see machinery in any foundry can be monitored remotely via cloud-based control system. Okay, so nowadays lot of so if you take example of we have what we call is the camera systems, right? So nowadays if you see all industry owners, suppose they are sitting somewhere in remote area and your industry is somewhere in Howrah, right? They can monitor sitting any place their industry what is happening, right? So that type of tools are developed today. Okay, so this is very cloud-based system. The entire data which is coming out from there, it will be stored. But they say that this data will be deleted after 15 days. Okay, you cannot keep the data. So that you need to store that data in a cloud where you have a lot of memories, but it becomes very difficult. There are a lot of challenges when it goes to cloud. A lot of cyber security problems and challenges will be there. Okay, so now the industry 4.0 and challenges for the foundries. So as I mentioned that the casting process simulation, computer modeling, okay, which we are already doing in our day-to-day industry operations, and industry 4.0 is the next phase of the digitization, and it is the combination of many technologies, which we say is the smart factory. And then we have talked about the digital twins and then cyber security. Okay. So now if you see in our industry, foundry industries, we are doing several operations. One is the scheduling, then core making, molding, melting, finishing, heat treating, machining, shipping, accounts payable, accounts receivable, payroll, inventory control, and maintenance. These are the different things are happening in the foundry industries, and you can imagine how much amount of data we are generating from these different operations. Okay, so vast amount of operations which will be shared through the uh, 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 in the cloud, in the digital threads and the data, and we will try to trust on our desktop or computers, okay, and handheld devices to do the things. But what happens that we are, as I mentioned, that there is a need of heightened cyber security. Okay, so cyber security becomes very important. Most of the foundries in India today, as far as I am aware of, they are not aware of these cyber security challenges. Okay, so some of the foundry industries, they have taken the action on the cyber security, and they have started realizing and implementing these tools, because security becomes very important. So, cyber attacks can be the real threat, okay, regardless of the size of your business. The cyber criminals are innovative, organized, and they have no morals. So we also need to be very innovative and organized when we deal with the foundry data. Our defense must be innovative and organized, and there is no simple solution to protecting your foundry's data. We must combine high-tech security with a culture of workplace security and employees training. So I am here emphasizing on the employees training. Employees training becomes very important when we are implementing these tools in the foundry. As all of you are aware that foundry is a laborious industry, lot of workforce is there, okay, but most of the time they are not well trained or well skilled with these new tools. So there should be a training program for these employees, so that they can implement and understand these new technologies, and then save their foundries. Okay, so some of the questions I can put here in front of you, that what practices, procedures, equipment can affect your foundry process. What will happen if a practice, procedure, equipment fails? What is required and how much time will it take to restore the failure? Is our network safe? Is our intellectual property safe? Is our supply chain safe? And what do we do next? So these are the different questions I was having in the mind. So I can put in front of you, and then we can have the further open discussions on these questions. Now, I have also seen the weaknesses which we all need to take care. When we talk about the Foundry 4.0, we have to understand what is our weakness. We all talk about the strengths all the time, but we never speak about the weakness. So we have to discuss about the weakness, and then we have to see how we can address and overcome those weaknesses. So first is we have no formal cyber security training program in foundry industries. Already foundry industries are lagging behind to implement these tools, but at the same time they don't have the formal cyber security training program. Individuals who have a company own PC are verbally instructed that do's and don'ts, but it is very informal in the companies. Most of the people are using the USB devices, internet, and we have some rules about the cell phone, but they are nearly impossible to enforce. Smartphones can do many things nowadays, okay, business emailing, networking, but at the same time, the risk is increased when you implement this. So Industry 4.0 foundry machines will be communicating with the maintenance manager's device about perspective management. Then we have the improper backups. Okay, we had several severe crash only to discover that the backup drive. Okay, so whatever data we receive from the different process parameters, we collect data somewhere, right? So we have to have a proper backup, and sometime this backup will be crashed and then we will lose the data. And then inadequate protocols and standards also are not there. And then poor malware protection. There are 100%, hundreds of malware applications today in the market, and we have a lot of problems. And another good protection from malware is very high quality daily backups we need to do. Okay, so we need to come up with a very high quality secure backup every day. Okay, so what should be the next? It is possible to retrofit smart technology to old plant. Okay, so we don't have to wait for new factories and equipment to take advantage of the industrial Internet of Things. Devices and equipment in our factories get smarter. We must also get smarter on how we use connectivity. The possibilities are endless, and by simply regarding integrating smarter open technologies, it will make foundries easier to upgrade in the future to Industry 4.0. So the final goal of implementing these Industry 4.0 tools in the foundry industries, where customers' orders are placed via centralized control system, as Professor Bandyopadhyay also has mentioned, that we have to come up with a centralized control system like MRP, ERP system, and the foundry manages its supply. But come to this point, right, we have several things to do. So what are the key takeaways which we can get from this discussion is, as technology has changed our everyday lives away from work, it is now time to see how it can improve our working environments. Okay, so we all need to work on the how we can create the skilled employees, or we can train the employees who understands these tools and they can implement these tools in their foundries, right, at several platforms, and then they can increase the efficiency of their products. We all need to get a better understanding of what can and can't be done with Industry 4.0, so that no we can make the smooth transition. Okay, so with this I end my discussion here, and now I would like to show you another presentation where I would like to demonstrate how we are working on um, implementing some of these tools. So I come from IIT Tirupati, which is in Andhra Pradesh, and so when I joined IIT Tirupati, I started Foundry 4.0 Students Activity Center, and in association with the Institute of Indian Foundry Men. And so Andhra Pradesh and then Tamil Nadu, right? All these southern region, I spoke to many industries, and then we sat together and discussed as we should do it. So I started, and this Foundry 4.0 Students Activity Center during the COVID, when COVID lockdown was there, and then I was working with industry through virtual mode and having several discussions and meetings, and then immediately after second lockdown, then we got some place where no we inaugurated this chapter, and then you can see here almost 30 industries, 30 industries
Sir,
people
Professor,
came.
sorry for the interruption, Professor. Can we conclude in next 5 minutes?
Yeah, I'm done.
As
I'm done.
Professor Dr. Sarman is waiting.
Yeah. So just 2 minutes. I'm just showing the
Okay.
slides. Yeah. So 30 industries people came and inaugurated this, and then from there we have done these several industrial events and discussed with our students as well. We brought students, and then some of these things we have introduced in our curriculum as well. Okay, so you can see we have also gone to several industries with our students visit, and then we have signed a MOU with IIF CET on conducting the digital manufacturing course for foundry employees. So then so this MOU we have signed and exchanged with the government, with the education minister, and then the first course we have started, where almost 10 industries, 10 foundry industries came forward, and they sent their employees for training. We had 1 month training program at IIT Tirupati. So you can see here the all foundry industry. So this course we started on automation for foundry industries, where 10 industries came forward and then they got all the training on different foundry 4.0 tools. And then uh, another course. So this is the course structure. Yeah. Yeah. So this is the course structure, and then if you want to have know more about it, we can discuss later. And recently we have conducted these courses, so they are the another industries. Yeah. Yeah. Okay. So with this, I stop here and thank you for your time. Yeah.
It was a very interesting and informative lecture. In a very simple way, you have introduced to us about the physical world and digital world, and also examples of smart complex systems. You have informed us about the digital twin model and also about the strength and weakness, of course, of the Smart 4.0.
Yeah.
If there is any other doubts, if your time will.
Yeah.
The questions.
Yes.
There is now here to Dr. S. Saravanan, who is joining us on virtual mode. Please.
With permission of the chair, because of the opportunity to felicitate
Dr. Ajay Kumar from IIT Tirupati. May I request Professor Dr. Sumit Chabri to kindly felicitate Dr. Ajay Kumar. Thank you, Dr. Chabri. Now over to session chairman.
I'm pleased informing you that the next speaker, Dr. Saravanan, has already joined us on virtual platform. I welcome you, Dr. Saravanan. And before I hand over the floor to you, rather the virtual platform on you, I just take the opportunity to introduce you very briefly. Dr. Saravanan is in metallurgical engineering, although his BE is in metallurgical engineering from Anna University. And before that, he did his mechanical engineering graduation from Coimbatore. These additional qualifications are very useful to the industry. 6 Sigma Green Belt certification, lead auditor for ISO 2001 and ISO 45001 system standards from ECB. He is awards, including the Business Foundry Executive Award from IA in 2013, Young Foundryman Awards, Distinguished Alumnus Award from Sri Krishna College of Technology in 2017. He has presented 15 papers, published 34 papers, and he is accomplished as a streamlining in the production process, project planning and execution, training and development, result-driven planning, operations and quality management professional with exceptional communication and team building skill. He started his career with as an engineer in software engineering industry, Coimbatore, and up to span of 3 years in 1997, he joined Inaugural Private Limited, where he still is. He's associated, started his career as assistant engineer, then went up to assistant manager projects, manager engineering and quality control, general manager operations, junior vice president, and presently from 2024, he is the associate vice president of the company Inaugural Private Limited. Over to you, Dr. Saravanan, please. Will you unmute yourself? Also, Mandavada, will you make a telephone call? Ask him to switch. Make a mobile call to him. Can you hear us, Dr. Saravanan? Please show your hand if you can hear us. Thank you. We can't hear you. Just unmute.
I'm audible now. Hello.
Hello. We can hear you.
Okay, I joined through phone. I think now I'm audible. Audible?
We can
to
hear
my
you.
voice?
We can see you. Please start.
Okay, sir. Thank you. So I'm sharing my screen now. So now my screen is visible. Hello.
We can see your screen. We can hear you. Please.
Okay. So first of all, I thank you very much to Professor Dr. N.R. Bandyopadhyay for giving me wonderful opportunity to speak about this industry 4.0, particularly this Foundry 4.0. I am privileged and honored in speaking among the August gathering. And also in the commemoration of late Haridas Nandi's 101, that is 101. Now I am talking about the transforming foundry operations for future challenges through indispensable IoT-enabled resource management. So actually, I have the presentation details like about IoT and about Indian foundry industry and what is the need of IoT for the foundry industry and prerequisites for IoT implementation and application of IoT in the foundry industry, examples of IoT implementation in foundries, benefits of IoT implementation and challenges in IoT implementation in foundries. So this is actually I have prepared my content, but I think the speakers already discussed a lot about IoT, the concept, everything. So I'm just skipping that particular thing, and I'm directly going into Indian foundry industry because I need to tell about Indian foundry industry a little bit, 1 or 2 slides. Then only you can understand what is the need of IoT for this foundry industry. So here already you talked about industry revolution 1, 2, 3, 4, and actually now we are in industry revolution 4.0, and I'm sitting 4,000 kilometers away, and I am presenting this presentation. That is also one example for this evolution of this industry 4.0. So now. The industry 4.0 is moving towards industry 5.0. That is started with this artificial intelligence and collaborative robots. It is called cobots because some of the mechanization or working with robots have some of the disadvantages. So for that, we need some flexibility. So we are going for industry 5.0 strategies because it is a human centric, because we need to work with robots as well as the human also. And then resilience is very much important here. And then people now talking about sustainability, how to reduce our energy consumption. So that is the talk of the hour now. So for that, now industries are slowly focusing on industry 5.0. So I'm just skipping these slides. And I think, what is Internet on Things? It is a physical, that is a network of physical objects embedded with software, sensor, and other electronic devices which are connected through Internet to enable exchange of data with other devices or persons, whatever, whenever, and wherever. So this is actually the definition of Internet on Things. So this is the one we are implementing in the industries now. So the architectural levels are there. So already we have discussed enough on these things. So I'm just skipping this. So this is the IoT model in the manufacturing industry. So embedded system, then sensors, actuators, cyber physical system. So this is actually the general IoT structure. And this is the component of industry 4.0 here. So autonomous robots. So now the robots, we are adding the artificial intelligence into that, and then simulation, system integration, Internet on Things, and cyber security. So that is also one important thing. Our professor, Mr. Ajay, Dr. Ajay explained, now people are working on this cyber security, ISO 27001, TISAX, many things. So customers, the customers who are the foundry, they are forcing the foundry to go for this ISO 27001 and TISAX, all those things, and cloud computing, additive manufacturing, augmented reality. So this is all now going, they are using for training purposes, big data analysis. So all those things is now as a industry 4.0 now. And before going into the implementation of IoT, in Indian foundry industry. Just a few things about Indian foundry industry. The first author, the first speaker, I think. I'm just getting some echo. Okay, so this is the growth of Indian foundry industry. So if you see the Indian foundry industry, the last 3 years, it is constantly we are growing. So in the year 2022-23, so we were doing nearly about 14.16 million tons of casting at the rate of about 10% growth. And then the industry, the industry revenue, it is coming around 16.0 million US dollars. And the major casting exports, it is about 3,940 million USD. So you can imagine the importance of this particular industry. And then this industry is contributing to all the other industries, because the foundry industry is the mother industry for all the other industries. And then this industry is contributing to other industries, so the castings. So aerospace, defense, manufacturing, that is a machine tool technology, infrastructure, everywhere, So if you go without foundry industry, all the other industries cannot survive. So that much importance is there for this foundry industry. And if you see the sector-wise consumption, so auto industry is taking the major portion of the castings. The total production, nearly about 32% of the casting auto industry is taking, and other industries also taking casting significantly. So then, the auto industry is totally depend on this particular industry. So if you see the car, this is this much castings we are using. So even if we are going with the EV industry, all those things, maybe engine can be replaced by motor. But, again, to produce motors, we need castings, maybe aluminum castings or something like that. But again, it is a foundry industry. And apart from that, transmission, brake application, all those things, we need castings. So without casting, difficult to produce one vehicle. So whether it is a four-wheeler or two-wheeler or truck, whatever it may be. But if you see the difference, the China, actually, it is producing nearly about 54 million tons of casting. And what we are producing, this is 21-22 census, it is 12.45. Now 22-23, it is about 14 million tons. But nevertheless, the difference is nearly about 30-35 million tons of casting, very huge difference. So it is very difficult to bridge the gap. So, but, lot of scope for improvement for Indian foundries are there. But we are struggling very much because of a lot of things. One is the getting skilled manpower. It is the one big thing our Indian foundry industry is struggling. And then technology wise, little bit we are lagging when compared to other nation, even we compare to China. So we are lagging a little bit on technology side. So the meeting the customer's requirement on QCDST, that is quality, cost, delivery, sustainability, and technology. So it is very, very difficult nowadays, because the quality on one side, it is increasing. The quality requirement is increasing day by day. And then the cost, because of the global competition, the cost of the casting is going down, because customer is asking more quality with reduced price. So foundries are very, very struggling to produce to meet the customer requirement, and delivery also, because on-time delivery is the challenging now because of the uncertainties in some of the areas, like the skilled manpower, and then the technological upgradation. Little bit we are lagging. So one side our economy is growing, auto industry is growing, but meeting the demand to that particular customer requirements on delivery side, the foundry industry is a little bit struggling. And nowadays, people are talking about sustainability. So carbon footprints. So now in 2026, from January onwards, the European government is going to put a requirement on CBAM. So, and then US is going to put norms on GHG, greenhouse emission, all those things. So this is also nowadays coming to an effect on the foundry industry. So how to manage this? So what is the solution for that? So here it comes the automation, modernization, and implementation of IoT techniques. That is the only way in future to meet the customer demand. So what is the limitation in the present PLC technology? So one is the limited security, and then the programming with machine language. So PLC, programmable logic controls. For that, the one who's need to study the machine language. Otherwise, programming is very, very difficult. And then even though PLC is there, the physical presence is required to collect data. So without physical collect the data, monitor the data. So for that, again, we depend on the human resource. And analysis, again, is manual. And then, the scattered data is sometimes of no use because I'm getting one data from one machine, another data from one machine. So we cannot do much on this scattered data. And then the limited storage of data is one bottleneck. And the machine language is understanding is also very difficult. So we need to convert into our understandable language. That is also one problem. And then very limited variables can be monitored, maybe one or two variables or maybe 5 variables in the present PLC system. And adding additional variables also a little bit difficult. So, and then connecting this through Bluetooth, Wi-Fi or LAN is also difficult. So these are all the difficulties in the present PLC technologies. So there, the IoT implementation has come to safeguard this foundry industry. So what are the prerequisites for the effective implementation of IoT? So first of all, we need automation. So without automation, going for IoT is very, very difficult. So for example, if we have this old center lathe or something like that, so we cannot get any data from that particular machine. So we need to go for some automation, whether it is a partial or fully. So the first and foremost thing is automation. And second one is standardization of the process. As long as the foundry process is concerned, it is a little bit difficult to standardize the process. Each foundry is following different process. And then, and sometimes, every day they are following different process also. So then it is very difficult to get the automated automation and then getting data continuously. So these things are having some practical problem here, standardization of the process. And then network equipment is needed. And then centralized connectivity deployment. We need a server and then we need to collect data on particular centralized server. And then from there, we need to distribute the data everywhere. So one centralized connectivity is required. And then strong cyber security, it is required now because everything is in online. So there are chances of hacking our data. So strong cyber security is required. And then the data transfer capability of machines. So sometimes, nowadays machines are IoT enabled machines are coming. So the old machines, it is very difficult to transfer the data. So we need to make those machines to capable of transferring the data. So that is very important. So what are the applications of IoT in foundry industry? So automated remote equipment management and monitoring. So that is the one. So now slowly we are implementing IoT in the foundry industry. So I will tell you some example. I will show you some example after this. So here we are not only monitoring the performance of the machine, but also we are controlling the machine also. That is production monitoring is one side because what the machine is producing, what is the quantity requirement, all those things. And similarly, the process monitoring, whether the process control is going as per the requirement also, that is also possible to monitor nowadays. And then predictive maintenance. So that is a very important thing, very important benefit, the IoT for the industry, not only the foundry industry, but for all the other industries. The predictive maintenance. So we can go for that is the stipulated cycles, and then after that we can change the spares or something like that. And not only the predictive maintenance, and for preventive maintenance also, it will be very useful. For example, we can monitor the motor heat. If the motor heat is excess and as per against the standard, then automatically the intimation will come to the maintenance supervisor, and then he can go and immediately attend the problem. Or sometimes if the motor heat is exceeding the stipulated limit, automatically the machine will switch off. So that is the possibility now. Because of that, because of the predictive maintenance, preventive maintenance, we can save a lot of money from the repair and then breakdown of machines, all those things. And then faster implementation of improvements through operational business intelligence, because the data is coming round the clock. What kind of data? Because for example, the MD is sitting somewhere else, even in abroad, and then he is monitoring all the performance of the particular company. So that the faster implementation, faster decision making is feasible nowadays. And then the inventory control. So here, the monitoring of raw materials. So what is the consumption level? Online monitoring. So that actually is the monitoring of the inventory control, inventory management is very much possible. I think I'm getting echo. I think someone should unmute your systems. Okay. So quality control, again, it is possible. So I think for that, our professor has already explained. Supply chain optimization, I will show you example here. And then plant safety improvement, HR management, again, now people started implementing attendance monitoring, all those things through IoT. So that is possible nowadays. And so this is very easily, companies are implementing this HR management, all those things. And material movement tracking, it is very, very important. I will show you an example here. So now, since we are working practically the implementation of IoT, I'm showing some examples here. So this is the general structure. So for engineering nowadays, so already this structure our professor explained. So here, what we are doing is control and monitoring the in-house machines. For example, core shooter machines, we are doing, we have implemented IoT systems here, heat treatment, and then molding machines, and then the CNC machines here. So CNC, it is a machine shop. So here, core shooters, some important parameters like temperature of the core box, pressure, shooting pressure, and then power consumption, and then timer we have fixed. And then because of that, we are monitoring the production rate. So all those things, we are actually getting data continuously by putting proper sensors there. And then all the data actually we are capturing from the machine and then transferring into the cloud. And then we are downloaded from the cloud. And then from the, from the machine, the direct readings we can see through mobile phone or even computers. And heat treatment furnace, we have implemented IoT there. We can monitor the temperature of that particular thing. And then, we can even set the temperature. We can set the process from remote. So that is possible. So we have implemented IoT system for heat treatment. And molding machines, again, so sand properties, mold count, productivity. So consumption, mold, that sand consumption, everything we can monitor. And similarly for CNC machines, continuously we are monitoring the production rate and then so please mute.
These mutes. These mutes. These mutes.
So for example, this is one IoT implementation we have adopted in our pressure die casting company. So here you can see station 1, station 2, station 3 everywhere, so that gives actually the production rate, temperature, everything. So this is online monitoring. So continuously, round the clock, we can monitor this particular production. So and then low pressure die casting system here. So LPDC machine, we have implemented this system, and then we can monitor the status of the machine, and then temperatures, production rate, so rejection, all those things we can monitor here. And then here the molding, the cell molding. So we have put a counter here. The mold production, it is continuously showing the mold production, and then these data actually we have captured from the machine and then put it in our computer here. And then we have put a lot of heat sensors here. So it is giving a lot of it is absorbing the heat from the molding machine, because cell molding we are heating the pattern. So for that, the heat is very important to decide the quality of the mold. So all these things actually we are monitoring here. So what is the temperature of the top box, bottom box, everything, and then what is the production rate. So everything, machine 1, machine 2, machine 3. So these are all the things actually we are getting the data from the machine, and we are monitoring continuously in the mobile phone as well as in the system. And also here, the complete the control of the machine is also here. So the operator cannot change anything in the machine. Even he cannot set the temperature. If there is any PLC or something like that in the machine, so the operator can sometimes change the parameters. But here, nothing can be changed in the machine, because everything is controlled only with the supervisor, and the supervisor is sitting in the office. He is controlling the complete all the 5 machines, 6 machines from the remote. So all the temperature and then production, everything is monitoring, and the total system, actually all those things, even our top management is also monitoring, sitting somewhere else. So this is a complete monitoring system. So core making machines, what are all the core shooter it is running, what is the production rate, everything we can monitor. So this is actually the heat treatment. We have implemented IoT here. So here, the data is transferring from the heat treatment furnace. So in the mobile phone, it is completely, it will show the curve. So what is the temperature range, what is the time, everything. So here there is a video. I could not run this video now. So the mobile phone, we can see the curve, live curve. And then after that, we can get the complete report like this, the total heat treatment cycle. And through the mobile itself, we can change the after completion of cycle. If one person is there to load the material into the furnace, and the supervisor can set the process from his home. So he can set the temperature, he can set the holding time, everything from his home itself. So it is completely, we are doing monitoring from the remote. And similarly, this is the molding machine, green sand molding machine. We have implemented one IoT. So here, what is there means the complete the production data we are capturing from the machine, just putting a sensor in the machine, and then it is actually giving the information. What is the part name, part number, everything through some RFID controls here. And then once the mold is traveling from this station to this here to that line, so that we have captured the count. So the mold count will come, and then already we put the database in the mold weight, everything. So according to the number of molds, automatically it will give the sand consumption rate. So like that, it will the data will come. So this is the start time, and what is the mold making target mold. For example, if the start time is 8 o'clock, so at this time, we need to produce 3 molds. Now actual molds, actually they produced 1, and then this is actually the sand weight. This is the individual mold weight. For example, here 2 molds produced. This is the cumulative sand weight it has come. So totally from this data, we can find out what is the actual sand consuming. And similarly, what is the target and what is the actual at that time. So that is also we can monitor. If there is something big difference, so immediately we can ask that supervisor or operator why the production is going slow, something like that. And if there is any breakdown, automatically it will show here. And similarly, we are continuously monitoring the energy also. So wow, energy consumption. So what is the energy consumption per mold? All those things, it is coming in the report. Hello.
Can you
Your voice, I'm getting some echo.
Can you come to the next
So this is actually the IoT what we have implemented. So here, some of the IoTs we have implemented in our melting. So are you able to hear my voice? Hello. Hello. So here, so here the calculation, the charge calculation based on the spectrometer results, it is very crucial. So here, so for that, we did some IoT implementation here. So based on that, based on the spectrometer reading, automatically the charge calculation, everything will come, and then just the operator will add the allowing elements what it has shown in the computer. That's all. So he no need to calculate all those things. So this is the spectrometer reading, and automatically that data actually transferred to the computer, and then the computer will give the alloy additions. So only thing, the operator will just weigh the alloy additions and then put the required material. And the next phase, we are going to do the automatic alloy additions here. And this is again the IoT enabled machine shop. So we have implemented a lot of things there that will give the continuous reading on the production, productivity, everything. So that will also we are captured in our mobile phone also, and then that big display. So this is for material handling. So right now we are working on this 3D printing machine. So 3D printing right now we are working on the core making. So here again, IoT enabled 3D printing machines are there. No, so when sitting here, just we transfer the CAD data. So and then automatically we can print the cores. So no need to go there and all those things. Only one supervisor, maybe it is required to see the machine performance. That's all. So this is actually the regular core and 3D printed core. And then material tracking also nowadays customers are using IoT. So complete because customer wants zero inventory. So for that, they are ensuring the availability of material at our end and their end, and then they are monitoring the material movement, the truck movement, everything continuously. And then because of that, everywhere, zero inventory can be maintained. So that is one good use for this IoT. And then this is the IoT enabled structures performance. We are continuously monitoring this kind of data dashboards we have. And then in this computer, it will give all the performance of the company completely. So these are all the benefits from IIoT. So threats and challenges, again, the foundry industry, it is dust and environment, it is little bit big things, implementation is little bit difficult. So for that, we need to select appropriate sensors, actuators, and then even, the transmitters, everything, it is suitable for the foundry industry. And then one big threat is the failure of IoT. IoT can have catastrophic consequences, creating high risk, because if there is any failure in internet or something like that, the total foundry will become a standstill. This is one big threat if we go with IoT. So these are all the challenges in implementing IoT in foundries. So atmosphere, more operation, more data, integration of machines, because we have old machines, we need to integrate. The integration of machine is become a very big challenge, and then more variables in foundry when compared to other industry. Foundry industry is having more variables. And again, the foundry people changing the mindset is again very difficult. So breaking the mindset of people is a very big challenge here. And then the standardization, that is also very much important here. That is also a big challenge. So I'm just skipping because of the time constraint here. So even though there are a lot of challenges, it is anyway there is no escape going for IoT implementation in foundry industry. Thank you very much.
Dr. Sir, thanks for
Please close it.
Talked about the sustainability of these industries in the future and the hybridization process of this industry's combination.
No, you are right. I tell you, Professor Bomo, you are right. What I wanted to impress upon in my today's lecture is that this transformation from a conventional foundry system to a foundry 4 arena, what are the steps and what are the difficulties to be faced by the conventional method to this, the contradiction between this. As regard to sustainability, if you can really implement 4.0 concept and principle of 4.0 industry, this will be definitely sustainable in its right perspective. Hybridization is like we are here to the hybrid mode. So that will be an automatic phenomena. As these people are telling about IoT, ML, IA, question is, in this world of third world country like ours, is it a feasible proposition? People needs to think over it. Thank you very much. That's correct.
Right?
Yeah.
And inanimate and animate process combination feature.
Okay.
There is no feature in the world.
Okay. Thank you very much.
Okay, Professor. Nice. Let me
So,
conclude it
before we-
and hand over the floor to you or
Yeah.
to my colleague here.
No.
Before the Honorable Session Chairman concludes, may I request Honorable Session Chairman to kindly felicitate the rapporteur of today's session, Professor Dr. Sumit Chavdi. May I now request our Honorable Session Chairman, Professor Devashish Desarkar, to kindly sum up and put up his concluding remarks.
We have had a very interesting session with three very good presentations. We started talking about the Foundry 4.0. Professor N.R. Bandyopadhyay very nicely discussed about the steps involved to reach 4.0 level. The next presentation, it's a very detailed one. All of us have enjoyed. Professor Ajay Kumar very nicely mentioned about the digital twin model and its important layers, and also the cyber security, which is very, very important, which our third lecture by Dr. Saravanan also touched upon. He very clearly and in depth, in detail, and in simple language, of course, he explained the need of IoT, its applications, effectiveness, implementations, and of course, the risk involved. Challenges for the Indian foundry, he highlighted, And so very useful information he provided about the statistics with regard to the Indian foundry cast product manufacture, its market demand, and also the global data. So all these three presentations were very, very informative. I do not know whether this can be put on the website or something so that we can refer back, as there will be no proceedings, I suppose. But if you can put on the, if any provision is available, with the permission of the speakers, they can upload it. It will be of great benefit, I sure. Thank you very much. Thank you.
Will be done. No, it's complete. Very good.
A very, very good evening, ladies and gentlemen, distinguished guests, dignitaries on the dais, off the dais, council members of IEI, former council members of IEI, all members of the West Bengal State Center Committee, all corporate members who are present here, the students. Today, we really had a very, very enriching session. This session has been, this is a commemoration program of our beloved late Haridas Nandi's 101 year birth anniversary. And this anniversary lecture has been converted to a one-day seminar like previous year, and the program has been conceptualized by Professor Dr. Inar Bandyopadhyay. A big round of applause for Professor Bandyopadhyay. We had the opportunity to hear from Dr. N.P. Sinha, Director, Alan Global Services, Foundry Park, Howrah, and he has focused on the fact that the foundry cluster in Howrah has now reduced from its legacy, and whereas the foundry parks in other parts of the country, they have grown significantly. We had the opportunity to have Dr. Devashish Desharkar as the chairman of technical session, and we also had our beloved friend Professor Dr. Sumit Chowdhury as the rapporteur of the technical session. Our heartiest thanks to this gentleman. They have conducted the session in a wonderful manner. We had the opportunity to hear from our beloved Professor Inar Bandyopadhyay. He has delivered the commemorative lecture and also elaborated on the theme of his lecture. Topic was the emergence of concepts of industry and foundry 4.0, reflection and introspection. Professor Bandyopadhyay needs no introduction in the fraternity of IEI, and he really practically single-handedly spearheaded this entire event. He curated the event, and today this has even become a success. A major part of the success credit goes to Professor Inar Bandyopadhyay. We had the opportunity to hear from very, very distinguished speakers. One of them is Dr. Ajay Kumar, Assistant Professor, Department of Mechanical Engineering, IIT Tirupati. He delivered the talk with the title, The Role of Digitization in Foundry Industry and Opportunities. It has been a wonderful deliberation. We all have learned from his deliberation. We are really thankful to Dr. Ajay Kumar for coming all the way and participating in this event. Dr. V.S. Saravanan, Associate Vice President Foundry from Indoshell Cast Private Limited, Coimbatore. He has joined online and delivered on transforming foundry operations for future challenges through indispensable IoT-enabled resource management. He has also enlightened us with his lucid presentation. And this program has been ably supported by engineer Subroto Chandra, our beloved Chandrada, who has nicely supported Dr. N.R. Bandyopadhyay for organizing this event and taking all the pain for minutely looking after all the necessary logistics and everything. Professor Dr. Raju Bosak, he has delivered the welcome address, and he has also mentioned about the 39th Indian Engineering Congress, which is going to be hosted in December 2024 at Novotel Hotel, Kolkata. After 8 years, the West Bengal State Center has got the opportunity to host the Indian Engineering Congress. And I am reiterating what he has said, that inviting you all to become a part of this gala event. And this event, we are expecting around 500 plus technical papers to be presented, along with memorial lectures and visionary talks and glimpses of the industry personnel. So it's an invitation. Once again, it is extended to you all. Please come and join us and support the event. And thanks, my sincerest thanks to all the council members present and past who are present here, and all the members of the West Bengal State Committee, all the staff members of IEI headquarters, and all the corporate members who has been here today, all the students. I'm sure they have learned, they have gathered a significant amount of learning today. And finally, to all the staff members of West Bengal State Center who had worked relentlessly behind the scene for making today's event happen. And with this, we conclude today's session, and I request the staffs of West Bengal State Center to kindly pass on the refreshment pack to all our members of the audience. Thanking you all once again.
Okay, thank you, Devashish. Thank you. Rana, Rana, যাবো আমি হ্যাঁ কোনটা দাঁড়া আমার